Morning, students. Uh, Today we are going to study our last chapter for the third term. It's chapter 21, solids. Okay, so solids, you know about solids. Some examples are rubber. Okay, the rubber that we use to erase. Rubber is a solid, and also the rectangular boxes which we see in rectangle type boxes which we see in a mill. Okay, that is which is in the tree, that is from extracted from a tree. Okay, so from the in mills we have stored the strong or large rectangular type boxes or solid type shapes there. Okay, and cuboids. Okay, cuboids are example that cubes which has that small cube that we used in the snake and ladder game. Okay, that is that small cube which is a solid one, and if it is empty it is not solid, but it is solid. Okay, it has matter inside it. So that type of things that we see in our daily life are solids. Okay, so here we have studying about solids and surface area and that type of dimensions which we use in solids, which we use for solids. Okay, so this is a small chapter. This will be your last chapter for the third midterm. Sorry, it is not the midterm, third annual. That term, that is the annual examination, for the annual examination. Okay, so let us start our chapter. So solids, surface area and volume of three-dimensional solids. 3D means three-dimensional solids. So what is a three-dimensional? What is three-dimensional? Yes, three-dimensional means it has three dimensions, which are length, breadth and height, or length, width or height and height. Okay, that's the three dimensions for three-dimensional solids. So for an introduction, what is a solid? A solid is something which occupies space and has a definite shape. That's the definition for a solid. Anything which occupies space, it is occupied as a space, and also it has a definite shape. Okay, it has a definite shape. And volume, the space occupied by a solid. A space occupied by a solid is its volume. You know about this. You have studied in your previous classes. And the capacity of a container is its internal volume. Volume, for example, we have used drinking a glass of water, right? So that glass is a container. Okay, and the volume of the glass is how much water does the glass contains. That's the volume of that object. Okay, so the amount of water that will be contained or that will be occupied by that glass is the volume of that glass. Okay, so that's the capacity occupied by a solid. Okay, and then the volume of a material in a hollow body, and that's the external volume minus its internal volume. That's the volume of a material which is in a hollow body. Okay, yes. And what's the surface area of a solid? Surface area of a solid is the sum of the areas of all the surface of a solid. All the surface of a solid. Okay, the solid surface, there will be there are surfaces of the solids. Okay, that surfaces are sum or added to be to find the surface area of a solid. Okay, and that is its total surface area. Okay, that's the three main things. And since a solid has three dimensions, solids has three dimensions: length, breadth and height. And so a solid is a three-dimensional figure. Okay, that's why three dimensions are there: length, breadth and height. That's why solid is a three-dimensional figure. Okay, is it clear for you? I think all of you clearly understood. And also in the same way, area is a two-dimensional figure. Why area is a two-dimensional figure? Because it has two dimensions, length and breadth. Okay, perimeter is a one-dimensional figure because it has only one dimension, that's the length. Okay, so that is one dimension, two dimension and three dimension figures. So perimeter is one dimension, area is two dimension, and then yes, surface solid is three dimension, that is volume is three dimension. Volume is three dimension. Okay, yes, that's the introduction part: solid, volume, surface area and three dimension figures. Okay, and next is the three-dimensional figure cuboid. Cuboid, which is a three-dimensional figure. So cuboid is a rectangular solid which has six faces, and each faces are in the shape of a rectangle. Okay, cuboid is a rectangular solid. It is in the shape of a rectangle and it has six faces. Six faces are there. Look at that figure. Yes, that figure is given. So it has it, and all the surface are in rectangle shape. Okay, look at that figure. It is clearly, you can identify it. Okay, that's the six sides are there. 1, 2, 3, 4. For the lateral sides and two surfaces are there. So 4 plus 2, 6. And each surface are in rectangle shape. That's the cuboid. And for a cuboid, these equations should be studied. Volume is length into breadth into height. That is L into B into H. First is, second one, total surface area. Total surface area. It is calculated as 2 into L into B, length into breadth, plus breadth into height, plus height into length. That's the equation. And lateral surface area of a cuboid is sum of all areas of the four walls or four surface faces of the cuboid. That is 2 into L plus B into height. That is the lateral surface area of a cuboid. And last one is the length of diagonal. If there is a diagonal which can be drawn, and that's the length is root of length square plus breadth square plus height square. Okay, and an important one is the length of the longest rod that can be placed in a rectangular box or in a room is its diagonal. The longest rod which can be placed in, that's length is the length of the diagonal. Okay, this is the four main equation that should be used for cuboid: volume, total surface area, lateral surface area and length of diagonal. Okay, and the next is cross section. What is a cross section? What does cross section mean? The cut, or which may be the cut which may be or which is made through a solid perpendicular to its length or height is called its cross section. Okay, if we cut a three-dimensional or a solid, okay, if we cut a solid from where it's perpendicular to its length, if we cut a solid perpendicular to its length, it is its cross section. Okay, and a solid is said to have uniform cross section if its perpendicular cut is of the same shape and size at each point of its length. if we say it's uniform cross section, uniform means yes, it is uniformly cross sectioned, which is same. Okay, that's a cut in the same way. If we cut it the perpendicular with the same shape and size at each point. For example, if we cut a spear, okay, through which is perpendicular, and then we get two hemispheres, okay, that is of uniform cross section. Okay, uniform cross section, we get semi-sphere. Okay, that's an example. And also there's given figures which is as example for you. That rectangular solid is cut into two. Face A, okay, sorry, face A and face B is given. Okay, that's given. And when a cuboid is cut through, for example is given, when a cuboid is cut through points A and B perpendicular to its length, the faces obtained at both the ends are of same shape and size. Therefore this cuboid is a uniform cross section. Similarly, for that a rectangular right circular cylinder, okay, that also have uniform cross section. But for a cone, if we cut a cone through its perpendicular as its length, we get two faces, okay, but the shape are and size are different. We get two faces but they are not same, which is not uniform. Okay, so if we cut the through the perpendicular to its length, if we get the faces of same shape and size, it is uniform. If we cut and we get the pieces which is not in the same shape and size, is not uniform. Okay, that's uniform cross section. So what is a cross section? Yes, that we cut a solid through its perpendicular to its length. Okay, that's a cross section. And uniform cross section, if we cut if this perpendicular cut is of the same shape and size of that of the length. Okay, yes, that's the one. And similarly, when a body has uniform cross section, the volume is area of the cross section into length, and the surface area is perimeter of cross section into length. Okay, that's the equation. And next is the flow of water. Okay, flow of water or a liquid. That is, if water is flowing through a pipe or a canal of uniform cross section, the volume that the water flows in unit time is area of cross section into speed of water, flow of water. Okay, this is very important one. That is, you know about water flowing through a canal or a pipe. Okay, if you are in a municipality area, you know there are pipes, okay, that flow water to our home for our household purposes. Okay, so that flow of water, if there is a cut, okay, if we cut that pipe, or we cross section that pipe, that volume of the water flows at this unit time is can be calculated. Okay, that is the area of the cross section into speed of water, speed of the flow of water. Okay, when we solve the example, you will be clearly understood. How many liters of water flows out a pipe of cross section area 5 centimeters square in 1 minute if the speed of the water in the pipe is 30 centimeter per second? So the speed of the water in the pipe is given, and the cross section, area of cross section of the pipe is also given. So you have to find the amount of water, the liters of water flows through the pipe of cross section. So for that, 1 liter is 1000 centimeter cube. You know. Then flow the volume of water flowing in 1 second. Okay, you have to find in 1 second. That is 5 into 30 centimeter cube. 5 into 30 centimeter cube, that is 150 centimeter cube. Okay, and for 1 second you have calculated, because the area of the cross section and the speed is given per second. So you have to calculate the volume for 1 minute. First you have to calculate the volume of 1 second. Okay, that's 150 centimeter cube. So for 1 minute, 1 minute is 60 seconds. So it is 150 into 60 centimeter cube, that is 9000 centimeter cube. 9000 centimeter cube, and which is 9000 centimeter cube. 1 liter is 1000 centimeter. So that is 1 liter, 9000 divided by 1000, which is 9 liters. Okay, this is how you have to calculate the volume of water that flows through a pipe or anything in unit minute. Okay, I hope all of you understood. And these are the main exercises for this chapter. That is, first is the flow of the figure shows a solid uniform cross section. You have to find the volume of the solid. All measurements are in centimeters, and assume that all angles in the figure are right angles. Okay, so the you have to find the volume. Okay, all sides, all length, breadth, height, all are given, and all are in the centimeter. The measurements are centimeters, so you can directly find the volume. Okay, clear. The next question is also given. Okay, so you have to find the cross section area. Okay, cross section is given, so you have to find the volume, surface area, like that. Okay, yes. So I hope all of you understood the class, and there are small things which you have to study. The area, the volume, total surface area, lateral surface area, and length of the diagonal of a cuboid. That is the first thing you have to study. And second one is the that's the cross section. Okay, cross section, what is uniform cross section and non-uniform cross sections, and the area of the cross section, volume of the cross section, area of the cross section into length. That equation is very important. Two equation, lateral surface area, and that two equation is very important. And also, how will you calculate the volume of water that flows through a pipe or a canal in unit minute, unit time, if it is a minute or second. It depends on the question. Okay, these are the three main important points in this chapter, and the exercises are given for you. Okay, 10 exercises are there. All of them are related to these three sections. Okay, so these are the exercises. Yes, so this is just a small chapter. This is all for today's class. I hope all of you understood the three sections which we have studied in this class. Please do these exercises. Okay, that's exercises, that's important one. And also there are workout exercises in your textbook. First solve that exercises, then do this exercises as homework question. Okay, please do that, work out that exercises problem which is solved in your textbook, then only come to this exercises question, then we will get as easy. Okay, and feel easy for you. And then please write the definition of volume. Okay, this please write as heading, and write the definition of solid, volume, surface area, and also two-dimensional figures. These should be written in your notebook. And then write the cuboid, definition of a cuboid, and then the volume, total surface area, lateral surface area, and length of diagonal. These four equations in your notebook. Okay, for this cuboid, and draw this cuboid in the corner side also. Okay, and then write the cross section, what does cross section means, and the uniform cross section, and the two type of examples that is given for you, and if possible write you can draw the pictures also, and then which is the important two equations for finding the volume and the surface area of a uniform cross section. Okay, write it, and then write the flow of water, the equation and the main equation, and write this problem and try to work out the problems which is given in your textbook. Okay, solved problems, and then work out these exercises problems. That's all for today's class. If you feel any doubt, you can ask me. So this is the whole for the year class. Okay, so you have to study for the annual examination, and this will be your last class. Okay, and the last chapter. Okay, please study the whole chapters which I have given for you from the first term. Okay, you have first, second and third term all chapters for your examination, annual examination. Okay, please try to answer, please try to revise the chapters, and if you feel any doubt in any section of this chapters which is in the first or second or third term, you can ask me. Okay, and there will be Zoom classes. Okay, for this 3 chapters which I have studied in, I have taught you in this third term. Okay, that will be on Monday and Tuesday. I will be given for you in the group. Okay, notification I will notify in your group. Please try to attend the Zoom classes, okay, that I have given for you. Okay, if you feel any doubt, please revise. Okay, there is no time, please revise your chapters which is in the first, second and third term. That will give easy for you, and the from today onwards, please revise it, and thank you for watching me and listening me, and I hope all of you understood that topic. If you feel any discomfort or anything, you can call me and message me anytime. Okay, thank you students, have a nice day.